Personal finance practice problem using OneNote. Excel functions, present value, future value, and number of periods calculation. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the Practice Problems tab in the 1112 Excel Present Value, Future Value, and Number of Periods tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculations on down below. We're going to be continuing on with a problem we started last time, but doing the calculations using new methods. So the information we had last time in a prior problem, and if you haven't looked at the prior problem, that's okay. We'll just recap it here, and then we'll move on to the new thing. So what the information is that we're going to assume the value of property is increased at a rate per year of 7%. So we're imagining we have some kind of investment, possibly stocks, possibly investment in land or something like that, a home that we expect to be going up in value, as opposed to some kind of asset that we have, such as a car or something like that, that we would typically think that would be going down in value over time. We want to think about how long it would take before the property doubles in value. Now, when we look at this specific question, there is that rule of 72 that's kind of the quick way to get there. And notice I can answer that question in essence without even having an actual investment. But it's useful to know what the investment is because that kind of grounds most people in really thinking about what's going to happen. So if we imagine the investment to be 1,000, for example, how long will it take for it to double? In other words, get to 2,000. So to use the rule of 72, we just take that 72 divided by the percent, but really not in percentage form, and we get an approximate answer of the 10.29. That's what we did last time. And then we ran a running balance, which is really helpful no matter what method you use. And it's much easier to do in Excel by basically seeing the interest calculations on a year-by-year basis. And we can see, once again, we get to 2,000 between years 10 and 11. So now we're going to think about in Excel, doing the same kind of calculation in Excel. Normally, when you work with Excel, with these present and future values, they can be kind of overwhelming at first. And obviously, we're going to look at this in OneNote. You can also go to Excel where we'll spend time in Excel working through it there. But we'll just kind of explain it here in OneNote as another kind of method that you can use. This is a method I highly recommend using for most people, and it's worth your time to kind of learn the Excel functions. But even if you do not know the Excel functions, you still want to have an idea of them to the degree that if someone calculates something with them, that you're not like out of nowhere, you don't have any clue of what's going on, because all they're doing is another method of what we did basically up top here. You can also see it will show it mathematically. You want to be able to tie these things basically together. Now we're going to start with a present value type of calculation, even though this is actually not a present value function type of problem in Excel, because the present value is probably the first function that you would learn with regards to these time value of money functions. We will then use a future value to work this problem, and then we'll use another kind of calculation for the payment function or the number of periods function. These are all ways that you can get to the same answer, and what we want to get to while using these three functions is the idea that they're all kind of related. These things, of course, are related. Now, when we look at these functions in Excel, they're not mathematical formulas, they're functions, and they're going to have components in it. So you could think of it kind of from an algebraic standpoint in that you're going to have certain arguments within the function, and then you're looking for the unknown, which is usually the name of the function. So in this case, we got the present value. So we're typically thinking of something that we're taking from the future, we're bringing it back to the present point in time, discounting it for basically inflation or the time value of money that we're going to be bringing back to a certain point in time. So we're going to need certain arguments in order to basically do a present value type of calculation. Now, note that if it was algebra, then you can kind of say, well, if there was any unknown other than basically the present value within the algebraic equation, then as long as there's only one unknown, I can rework the algebraic equation to find the unknown, and you basically rework the algebra. Now, you can do a similar thing here, but you can't really rework the function. There's two things that you could do. You could say, if I know the present value function, but I don't want to solve for present value, I want to solve for some other argument in the function. I have some other unknown that is part of the argument in the function. Then you can't really rework the function, although you can look for another function that is related to that argument. That's method number one. Or method number two is you could basically use a goal seek type of function and basically ask Excel to use trial and error to back in to the equation. So let's see if we can kind of explain this here. We're going to say if we had a present value function, and we'll talk about how to put this into Excel two different ways, then we're going to be solving not for the present value, but for the number of periods, meaning how many periods will it take for this to get to 2,000. So the things we know that there's a 7% rate that we're looking at, and we know that this is 1,000 as of the starting point, and at the end point, we want this to be 2,000. So that's going to be the future value that we're looking at. So if we look at our argument down here, this is going to be basically an argument within Excel. This is one way that you can see these formulas, and this gives you a little bit more detail. You're going to pick up the rate. Now the rate here has a cell in it because I'm picking up the cell from the argument up top here, and that's going to be something that's useful to do in Excel, because instead of hard coding the 7%, meaning typing it in, it's useful to take it from a set of data so that you can then adjust the set of data and run different scenarios easily. So we get this number, which is the 0.07 or 7%. Then we have the number of periods. The number of periods is coming from this cell, which currently is at the 10.2447 about. Now, this is actually the answer. This is really the unknown. So if we didn't know what this cell was and we were trying to back into it using the present value, then we could put something other than the answer here. We could guess and just put like 5 or something like that here, solve for this, and then use a tool in Excel called goal seek to basically say, Excel, would you make this number what it needs to be to get to this end result to be the 1,000 present value? So hopefully that'll make a little bit more sense. We'll do this a couple different times. So we've got this cell here. That's going to be that's the 10.22. The number of payments is 0. Now we'll practice this multiple times as well, but just note that we use the same function for the present value as well as the annuity, present value of 1 and present value of an annuity. The difference between present value of 1 and an annuity is that in an annuity, you have multiple payments that will take place. And if it's not an annuity, then you're not going to have anything in this payment. You could either leave it 0 or you could put a 0 in it if you so choose. And then the future value, we know what the future value will be, meaning where do we want to be at the end point. That's going to be the 1,000 times 2, because it needs to be 2,000 here to double our investment. So we got 2,000 at the end point. Now, when we work this, we get to then that 1,000 as the answer. The only reason we get to the 1,000 as the answer, though, is because we already have the answer here at that 10.24. Notice if this number right here was anything other than 10.24, then I can use this function, which is calculating using all the variables here, and ask Excel. I could say, hey, Excel, would you change this, say we put 5 here or something like that, to whatever it needs to be in order to make the end result what it should be, which is 1,000, our starting point. And then Excel will basically do trial and error. In other words, Excel will kind of do the same work as we would do algebraically when we were solving for an unknown, reworking a problem to solve for an unknown. Excel will kind of do it, but instead of reworking the problem, they'll just basically plug in the number using trial and error to get to the proper function. So that would make more sense if you want to take a look at it in Excel. We do cover that and go through it in Excel. You could take a look at it. This is the second way that we can kind of do this. Notice you can use this dialog box up top in Excel, or you might see Excel kind of formatted in this format. Now, this is the shorthand format, which is much easier. Once you get used to a function, you want to use this format. So when you're not used to a function, you might use this big old dialog box. And then once you get used to the function, you'll get down to this small kind of box. This will be the end result no matter which function or which way you enter the function in, because, if you double click on the cell, no matter which way you do it, it'll look something like this. So we got the same numbers here. This is the same calculation, but we're going to see it in this little format. So now we got the present value, and notice it gives you this little dialog down below that helps you to calculate the argument. So you have to type in equals, and I'm going to put a negative because if you don't put a negative here, then it'll make the answer a negative. Now note that many people will argue, and if they're correct, basically that you should kind of put the negative on the payment right there on this one. But it doesn't really matter from a practical standpoint, and I kind of like putting it at the beginning, basically taking the full function and putting a negative at the beginning kind of like multiplies it times -1, or in other words, it flips the sign. So I'm going to say equals negative, present value is the function, PV, brackets to start the function, and then we go to our little arguments down here. So the rate is going to be the rate. We picked that up at B3, which is going to be that 7%. So the cell that 7% is in is B3. Then you type a comma. That will switch the argument or change the argument to the next data input, which is the NPER, which stands for the number of periods. The number of periods, this is actually the unknown. This is what we do not know. Now, once again, we could then say, well, if I don't know it, I'm going to try to just guess a number down here, like 5 or something like that, solve for it using that number, and then use goal-seek down here to ask Excel to fix that number to what it should be in order to get the result that I know it should be. Or I can look for another function that has the name NPER, which Excel most likely has, and I can use that as kind of like the more direct method or function. And that's kind of the equivalent of using your algebra to basically solve for this unknown. You're going to say, I can't rework this algebraically, but I can look for another function where Excel made one that has the NPER calculation. So in any case, we're going to pick up this number, which already has the answer in it. And then we have comma. Again, this is that payment argument, which once again is there for an annuity, not for a present value of 1 calculation. We're not talking about multiple payments here of $1,000, but just 1. Therefore, we're not going to use that. You can either just put 2 commas, or sometimes when you're starting out, I find it useful to put a 0 in there just kind of as a placeholder, and then another comma. We then have the future value. The future value should be 2,000 because we're going to double this. And I would put that in there by taking this 1,000 times 2 so that I'm referencing the table as opposed to putting hard-coded or typing in the number here. So I got that times 2. And once again, that's going to give us our 1,000, which is what we were looking for. And then, again, we can use goal-seek down here. If I chose something other than the 10.42, if I chose 5, then I can ask Excel to use trial and error with a tool called goal-seek, which basically says, Excel, would you please set this cell that has this function in it to be what I know it should be, which is 1,000, which we hard code in there, 1,000, by changing this cell. And then Excel will actually just simply do the trial and error. It'll just use brute force to find the answer, and it'll find the answer in that format. Now, note we can do the same thing using the future value calculation. And this is hopefully going to give you an idea that these calculations are related. And we can use the future value calculation using that goal-seek method to do the same thing and get to the same answers. So if we did this with a future value calculation, it would look like this. We're going to say, okay, well, if I take this same data, the only thing I don't know is the number of periods. Once again, we could start with that number of periods at like 5 or something, run the function, and then ask Excel to change this future value to what we know it should be, which now is 2,000, because we're looking for when this 1,000 doubles to 2,000. And we want to say, hey, make that 2,000 by changing this cell. And we can once again solve for the 10.24 years. So if we looked at this in the function dialog box for a future value as opposed to a present value, we would pick up the rate. That's still going to be the 7% that we can see here, 0.07. This cell, the number of periods, is picking up that 10.24, which is the answer, but we can imagine it to be like 5 or something like that, something other than the answer, which would give us a result other than 2,000, which we would then change using the goal-seek. And then the payment is, once again, not there or have a 0 in it because this is not an annuity calculation. And then we're going to say the present value would be whatever's in the cell 1000 here. So now we got the 1000 here. This is what's different because we're looking at the present value as opposed to the future value in the last one, which was the 2000. So now we're going to solve to where we will be at the end of this, which we're setting to be at the 2000. So if we solve for that, we get the 2000. And then again, the reason we got 2000 is because we knew this answer at the 10.24. But if this answer was something other than 10.24, we would get something other than 2000. And then we can go in and use the goal seek feature and say, Excel, would you set this cell to be whatever it needs to be to get that number to what we know it should be, which is 1000 times 2, doubling it 2000. So we can also see this function, this future value function, in this format. And this is the format that you'll learn to start typing it in as after you practice with the dialog box a few times. Same answer here, same thing. But now we got the equals, negative future value. Notice I have a negative sign. Most people would, or a lot of people would argue that you should put that in the payment, in front of the payment. But again, I don't think there's really a lot of value. I like putting it up front here to flip the sign. Otherwise, you'll get a negative value, negative 2000 as the result. So then it has the future value, FV brackets. You're going to pick up the rate, which you could hard code at meaning type it in there at 0.07. But I like to pick it up in the data up top. So that B3 is pointing to that 7%, comma, which changes the argument to the NPER. That's the unknown, which we're imagining we guessed here. This is the actual answer, but we can imagine we guess it to be like 5 or something like that as our starting point. Or we look for another function that Excel has that solves for the NPER, which we'll do in a second. So that's going to be the M5 and then comma. There is no payment because this is not an annuity calculation, but a future value of 1 calculation, meaning there's not a series of payments, but just one payment over time. And then comma, that gives us 0. You could put 0 or just 2 commas. And then we got the present value instead of the future value because this is a future value calculation. So we need to start at the present value. The present value we're starting at is the 2000 and the 1000, and we want to get to the 2000. So this then gives us the end result, the future value of the 2000, because we already have the answer down here at 10.24. If this answer was something other than 10.24, if we guessed it just to be 5 or something like that, then we could use goal seek and say, Excel, would you please set this cell right here to be what we need it to be, which is 2000, 1000 times 2, or double the investment, by changing this cell. And then Excel would just use its trial and error kind of format to figure once again to that 10.24. So notice you can find that 10.24 using kind of the rule of 72, although that's not exact. You'll remember if we get up to the rule of 72, gave us the 10.29. So the rule of 72 is an estimate. This is an estimate right here, although we could make it more exact as well. But notice it gives us that nice interest format. These then are going to be more exact. They give us the 10.24 if I use the present value, or if I use the future value and the goal seek. Then I can use the other method as I can look for that NPR, the number of periods. This is a function you'll probably be less familiar with. You'll probably be more familiar with the present value and future value calculations, or you should be, because those are the main kind of calculations. And I really highly recommend getting used to this idea of the goal seek, because that will apply to any function where you have one unknown argument and you want to basically solve for that unknown argument and you don't know what the other kind of function is. You don't need to find the other function. You just basically can solve for it in this format. So then let's use that last one here. So this is the future value calculation. We did that one. So now we're going to go to the number of periods. Now this would be the most direct way we can do this, because this is actually what we're solving for, the end result of that 10.24. So same kind of data down here. We got the rate. This is in the function box. We've got the rate, once again being the 7%. There is no payment. Again, we can put a 0 or just leave it blank because it's not an annuity. And then we got the present value. The present value we know is our starting point. That's the 1000. And the future value we also know because that's our ending point, and we want this thing to double. So we're looking for it to double. So I pick that up times 2. That gives us the 2000. Now note, this is one where you have to put the negative on the present value here. If you do not, then Excel will not calculate it. You'll get like some kind of error calculation. So if you get an error calculation or something with these present value, future value, time value calculations, then it's maybe because you're not putting a negative somewhere where you need one. So check that out, test that out. And that'll give us the 10.24 directly. We can also see that in this format. So this is the way you type it in once you get used to Excel, or the way Excel will show it if you simply double click on a cell. That'll be equals the NPER. And notice once again that NPER is the unknown that we kind of saw up here. So if you're looking at a function and you're saying, I wish I could just solve for this NPER one, again, you can use goal seek, or you can look for the function of NPER and see if Excel has that function for the unknown component. Here, of course, they do. The rate then is going to be that 7%, comma. That gives us the payment function, which you can either just put 2 commas in a row, or you can put this 0 as a placeholder, which I find useful. I did when I was starting out. It made me, it feels like that 2 commas seemed wrong to me for some reason. And then a comma again, and that'll give you the present value, which is the 1,000. And then a comma again, and that'll give you the future value, which you could put 2,000, but what we want to do is use our data up top. So I'm going to pick up that 1,000, which is this cell, times 2 to get to the 2,000, so that if I wanted to change this first number, I can do so, and this cell will populate and adjust appropriately without having to reformat our function over here. Once again, that getting us directly to the 10.24. Notice that once you get good at these arguments, you get to this 10.24 in this format, but it's somewhat magical once again. You get there and you're like, it's 10.24. It doesn't give you as much information as a running balance type of calculation up top. So if you do these running balances that we saw in the prior presentation, that actually tell you what is happening with regards to the interest on a year-to-year basis or period-by-period basis, can be quite useful. Obviously, if you're talking about a very long time period or compounding, and a lot more compounding, you might not be able to do a list like this. But even if it's a pretty long thing, if it was a 30-year loan or 30 years or something, you can basically go out with Excel pretty easily and build a table like this, and it could give you some more context with regards to this. So the functions in Excel are probably the most used. That's what you'd like to get used to. Much more reliable than the rule of 72, and much more flexible. The rule of 72 is reliable, but it's restricted to a certain spot. It's an estimate, number one, and it's restricted to just that doubling component. Whereas, of course, if you learn the present value, future value calculations, you can work a lot more flexible kind of problems. And then if you learn this running balance calculation, you'll get a better idea of what the actual compounding situation will be. Now, we'll also take a look at it in formulas. Formulas can be useful, but they get a little bit abstract when you're looking at these time value of money formulas. So they can get a little bit abstract. So they're useful, but even with a formula, oftentimes the result seems somewhat magical, and you don't really know. You don't really have a feel for it unless you were to basically plot it out in something like a table like this, I find. We'll also use tables. Tables are built so that you have an easy table to use before, and those were really useful before we had like financial calculators and Excel and whatnot. They're still useful for test questions when the proctor wants to take away your calculator. So that's usually when the tables are going to be coming in useful.